Okay, yay! Now we get to start my favorite part of this unit, and probably the most important part we're going to do this year in preparation for pre-cal and calculus. Um, this is probably the thing that you can use the most, I would say. So let's talk about it. So this is our trigonometry unit. So what is trigonometry? Well, trigonometry is just the study of triangle measurement. So this will allow us to calculate missing sides and angles of right triangles. So there's another way that we'll talk about in pre-cal of how we can use trigonometry to find missing angles and sides of any triangle, but for purposes right now, this just applies to right triangles. So we talked last week about our special right triangles, the 30, 60, 90, 45, 45, 90 degree triangles. And this will allow us to find angles and sides of any right triangle. So let's talk about our trigonometric ratios. These are so important. So each acute angle of a right triangle has the following trigonometric ratios. So we always know a right triangle has one 90-degree angle, and then this allows us to find all the other things. So the first one we have is sine, and this is the ratio of the leg opposite the angle to the hypotenuse. So let's say we're trying to find sine of angle A. So that means I'm just going to put a little theta symbol there. That means that we're looking for the opposite side to that, which of course then would be A. So we're going to write this ratio as A over, and then our hypotenuse, which is C. So if we were trying to use that angle A, we would write sine as opposite over hypotenuse. That's A over C. What about if we're trying to find angle B though? So if we're trying, my eraser won't work. My pen won't work. Okay, we'll wait for my computer to unfreeze. So if we're trying to find angle B, there we go. That means we're gonna put that theta on angle B now, and that changes that opposite side. Now that opposite side is this leg, B. Now it moves. B, and still over our hypotenuse, which is C. So you'll see that depending on what angle you're using, your ratio is going to change. All right, now let's talk about cosine. So cosine is the ratio of the leg adjacent to the angle to the hypotenuse. So remember, adjacent means it's touching that angle. So if we were looking to try to find the cosine of angle A, instead of the opposite like sine, we're going to go for this leg that is touching that angle. So the cosine of A is B over our hypotenuse, which again is always C. And now let's say we want to find the cosine of angle B. We put our little theta right there for angle B. We're looking at the side that is the leg that is touching that angle. That would be A. And then over our hypotenuse, which is C. And then we have tangent. Tangent is the ratio of the legs. It's just the ratio of the legs. We don't even use the hypotenuse. So it is the opposite to the angle over the adjacent to the angle. So let's say we're trying to find tangent of this angle right here, tangent of angle A. That would be the leg opposite, which is A, and then the side that's touching over B. And tangent B would be here, and it would be the side opposite, which is B, over the touching, the adjacent, which is A. And you'll see that those are just flipped. Okay, so this is the most important thing to remember for remembering these ratios, and it is SOHCAHTOA. We write it SOHCAHTOA. This will help you, I know it doesn't really make a whole lot of sense right now, but it will make sense when you're trying to solve these problems. It will be so helpful to remember. So what it means, means sine is just the opposite over the hypotenuse. Ka is cosine is adjacent over the hypotenuse, and TOA is tangent is the opposite over the adjacent. Now, that's not going to help you remember what adjacent and what opposite and hypotenuse are, so you really need to make sure that you understand all those parts of a right triangle and what those terms mean. All right, let's do some examples. So this is how we're going to use it. It's going to help us get these ratios, and then in the next section, we're going to show how we use those then to find missing sides and angles. Okay, so let's say we have this nice little right triangle here. All our sides are given to us. If they're not, we can use Pythagorean theorem to find one of the sides. All right, so we want to find sine of angle A. We're going to put our little theta here, and let's use that. So sine we know, so opposite over hypotenuse. The opposite leg to our angle is 5, and our hypotenuse is 13. So our ratio is 5 over 13. Now let's find cosine of A. Remember that cosine is ca, it's adjacent over hypotenuse, so the adjacent leg is 12, and our hypotenuse is 13. We always see if we can simplify our ratio. We can't here, so we leave it. Tangent of A then is going to be our TOA, opposite over adjacent, so it's our opposite leg, which is 5, over our adjacent leg, which is 12. Okay, now we're going to do this for angle C. So we're going to move our little theta symbol right there. And so now for sine, we are looking for opposite over adjacent, and now opposite side is 12, or not opposite over adjacent, opposite over hypotenuse, sorry. And our hypotenuse is still 13. Cosine of C will be the adjacent leg, which is 5 over our hypotenuse. And our tangent will be opposite over adjacent, so that's going to be 12 over 5. So you'll start to recognize patterns. One thing you can see is that these are the same, and these are just swapped. Okay, let's look at our next example. You'll see we don't have a side, so we need to find that side. So we're going to do 16 squared plus x squared equals 34 squared. We're going to get x squared equals 900, and that means that that missing side is 30. Okay, so let's find sine of L. We'll put our angle here. Sine is opposite over hypotenuse, which means it's 30 over 34, and we can simplify that fraction. Both can be divided by 2. So we get 15 over 17. To find cosine, again, it's the adjacent over the hypotenuse, so that's 16 over 34. We can simplify that to be 8 over 17. Okay, tangent. Tangent is going to be that opposite over the adjacent, so it's 30 over 16, which simplifies down to 15 over 8. All right, so sine of M, now we're looking at this angle. So sine is opposite over hypotenuse. That's going to be 16 over 34. We already know that simplifies down to 8 over 17. Cosine is going to be adjacent over hypotenuse, which is 30 over 34, and we know that simplifies down to 15 over 17. And then tangent of M will be opposite over adjacent, which is 16 over 30, but we know that simplifies down to 8 over 15. Okay, so now let's talk about how we use this. So we can use trigonometry to find side lengths. You'll see that we can't use Pythagorean theorem here because it's we don't have a second side. We are missing two sides, but we have an angle and we have one side. So we're going to use these ratios and then use our calculator. The first thing is right here. Please, please, please go check your calculator before we start all of this. This can hurt you so much if your calculator is not in degree mode. If you are unsure of how to put it in degree mode, come see me. I'll put your calculator in degree mode. but there is another mode that it can be in. And if you're borrowing someone's calculator that is in a level of math that is algebra 2 or above, there is a good chance that their calculator is not in degree mode. So please come see me to check your calculator or check your mode. Okay, once your calculator is in degree mode, we're going to set all these things up. All right, so we have an angle here, and we're trying to find x, which we can see is opposite our angle. And then we have a hypotenuse. So we have to ask ourselves, I'm going to write SOHCAHTOA over here. We have to determine, based on the information they gave us, we're not going to add any information in, what is the best method to use. So if we have this angle, we have opposite, we have hypotenuse. What uses opposite and hypotenuse? We'll see it's sine, it's so. So we're going to do sine of 28 degrees is equal to our opposite, which is x, over our hypotenuse, which is 19. And now we're going to solve for x. So we're going to multiply both sides by 19. We get 19 sine of 28 degrees equals x. You are just going to type that right into your calculator. So there's a sine button on your calculator. You're going to go 19 times sine 28, hit enter, and you should get x equals 8.9. It is that easy. Let's look at the next example. So let's look at the information we're given. Here's our angle. We are given an opposite side from the angle, and we're also given the adjacent side. So that means that we're going to use tangent because that is opposite over adjacent. So tangent of 41 degrees is equal to our opposite, which is x, over our adjacent, which is, 32. And we're just going to multiply both sides by 32. So we get 32 times tangent of 41. We're going to put that in our calculator, and that's going to give us x equals 27.8. All right, let's look at the next one. We have 43 degrees right here. That means that this is adjacent and this is a hypotenuse. That means we're going to use cosine. It's adjacent and hypotenuse. So cosine of 43 degrees is equal to our adjacent side over our hypotenuse, which is x. So we're going to solve for x. We got to get the x out of the denominator. And so when it's like this, all we have to do is swap these two. I can show you the algebra if you'd like, but in the end, that's what's going to happen. So it's just going to be x equals 36 divided by cosine of 43 degrees. Into your calculator, you're going to enter that, and you're going to get x equals 49.2. All right, this next one, we're looking at 33 degrees. This is opposite of 33 degrees, and this is our hypotenuse. That means we're using opposite over hypotenuse, which is sine. So sine of 33 degrees is equal to the opposite side, which is 15 over x. And again, we swap those. We get x equals 15 divided by sine of 33 degrees. Into our calculator, we input that value and we get 27.5. I'm not going to do these last two with you. I'd like for you to try to do them on your own, but I will give you the answers. So this one, you should get 24.3 for x, and this one, you should get 4.8. So try solving those two on your own, put them in your calculator, see if you get those values.